Swarm robotics is a field of robotics that draws inspiration from the collective behavior of social insects, such as ants, bees, and termites. It focuses on the study of large groups of relatively simple robots, known as a swarm, that work together to accomplish tasks and solve problems in a decentralized and self-organized manner. The key characteristics and concepts associated with swarm robotics include decentralization. Unlike traditional robotics systems that often rely on a central controller, swarm robots operate with minimal or no central control. Each robot in the swarm typically makes decisions based on local information and interactions with its neighbors, leading to emergent group behavior. Self-organization. Swarm robots exhibit self-organizing behavior, meaning that they can organize themselves into patterns or formations to accomplish tasks efficiently. This behavior emerges from simple rules followed by individual robots. Scalability. Swarm robotics systems are designed to be scalable, meaning that the number of robots in the swarm can vary, and the system should still be able to function effectively as the swarm size changes. Robustness. Due to their decentralized nature and redundancy, swarm robotics systems tend to be robust against individual robot failures. If one robot malfunctions or is removed from the swarm, the overall system can continue to function. Cooperation and coordination. Swarm robots cooperate and coordinate with one another to achieve common goals. They may use various communication and sensing mechanisms to share information and synchronize their actions. Exploration and coverage. Swarm robotics has applications in tasks such as exploration, where a group of robots can explore an unknown environment collaboratively, covering more ground efficiently than a single robot. Search and rescue. Swarm robots can be used in search and rescue operations, where they can navigate through complex and hazardous environments to locate and assist victims. Agriculture. In agriculture, swarm robots can work together to perform tasks like crop monitoring, planting, and harvesting. Environmental monitoring. Swarms of robots can be employed to monitor environmental conditions, such as pollution levels, wildlife tracking, or weather data collection. Military and defense. The military has explored the use of swarm robotics for tasks such as surveillance, reconnaissance, and coordinated attacks. Modeling natural systems. Swarm robotics research often draws inspiration from natural systems, like insect colonies or flocks of birds, to develop algorithms and strategies for robotic swarms. Researchers in swarm robotics use various algorithms and techniques, such as swarm intelligence, artificial potential fields, and bio-inspired approaches, to design and control these robotic systems. The goal is to create flexible and adaptable systems capable of solving complex tasks efficiently through collective intelligence and cooperation among individual robots.